Rotating compressors are used in small refrigerant appliances. Usually they're rotating vane type or stationary blade type. This is how a rotating vane rotary compressor works. The vanes in this are spring-loaded, so they move in and out from the rotating shaft. And this is rotating counterclockwise, so you can see how it comes in. The vapor that is blue, it gets compressed as the vanes push it around to the smaller section and out the compressor. Here's a stationary blade rotary compressor. Doing kind of the same thing. It just uses a larger round shaft in the center instead of the little vane fingers. Blade or vane construction, rotating vane compressors. There are 2 or more blades made of cast iron, steel, aluminum, or carbon. Vanes push out in and out by a spring or a centrifugal force. Stationary blade compressor blades fit in a slot in the compressor housing, always spring loaded. Scroll compressors are the king in residential air conditioning. I would say they're probably 70 to 80% of new product coming out, mainly in residential air conditioning and heat pump applications. There's fewer moving parts to have a problem, less internal friction. Some of these scrolls and compressors, the interior parts don't even touch each other. It works real well. And there's a very smooth compression cycle. They put out less noise, less vibration. They're just really great units. I don't know if they have a higher failure rate, but in my experience, I do seem to change these out more than a reciprocating compressor. But they are very energy efficient. In this lecture or the next lecture, you will see how these systems work in animation. But this is the way the system works. Screw compressors. Don't see a lot of these out in the field. They're mainly in large commercial applications. But here's some information on it, and we'll also see some I think at least one video of how these work. Screw compressor have different varieties. There's the open drive system, hermetic system, oil injection, and single screw compressor. Centrifugal compressor, vapors fed into the casting. The impeller spins rapidly in the casting. The force throws the vapor outwards, causing compression. Construction of this compressor: no valves, pistons, or cylinders. It has a stator and impellers. You'll see these a lot in motors and blowers. Same components. Well, they're manufactured differently, but the same concept. General compression components systems. They have service valves, mufflers, cooling systems, lubrication systems, unloaders, sealing device, and crankcase heater. We don't see a lot of crankcase heaters in the Florida area because we never get that cold. But imagine a business that is in the middle of winter, snow on the ground. They still need air conditioning because of equipment or groups of people. The air has to be dehumidified and cooled even in the middle of winter in large buildings. So to keep the oil from getting stagnant inside that unit and not lubricating, they keep the oil warm with a crankcase heater. So when it starts up, it's lubricated. Service valves, often bolted to inlet and outlet of the compressor. And you might have already used some of these in prior classes. It's used for recovering, evacuation, charging, pressure reading, and components of the system like low and high temperature switches. Mufflers. Most modern systems have these built in to the inside of the condensing unit or package unit. They reduce noise. They help the system actually work better. It causes less dramatic pressure pulsating inside the unit, causes the flow of refrigerant to move evenly, which creates a lot less noise. And they're often installed vertically to trap condensed refrigerants during the off cycle. Compressor cooling system. Source of heat is usually to compress vapor and friction of moving parts in the compressor itself. The method of cooling is circulating oil, cool suction vapor, water cooling, and fan. In most residential systems, it's either a condensing fan on top of the or on the side of a condensing unit. And the real item is the cool suction vapor. Remember, when that vapor comes back from the evap coil, that vapor could be as low as 45, 50 degrees, which helps the compressor from overheating. As you probably learned in HAC 150, we have lubricants. Lubricants are used in many ways, but they have to be compatible with the refrigerant. So different refrigerants have different lubricants. For example, the old R22 system refrigerant uses like a mineral oil, where the 410A uses POE oil. Here's some information on how pressurizing lubricant in a system works. Unloaders. Temporarily reduces pressure in the compressor during startup. The good way to explain this, I would think, was unloaders in some systems are mandatory. There's just no way you can run the system without it. Think about a steep hill, the steepest hill you've ever seen. Now in Florida, there's not many of them, but other parts of the country, there's a lot of them. Being at the bottom of the hill and being on a bicycle and trying to ride that bicycle up the hill from a dead stop, it's very hard to do. So an unloader it levels out that ground. So you get a running start on a level ground, then you hit that hill, you can make it up the hill. But in this case, it's very difficult. So we have unloaders to release the pressure of that hill. Here's how an unloader works. I think I have a video coming up that will show you how this system works. Sealing devices. Locations usually between mating parts, either to seal or to protect. The common types are gaskets and O-rings. For some reason, this picture I don't see an O-ring, they're just gaskets. Crankcase heaters, we spoke about this. This keeps the internal temperature of the oil or the liquids in the system to be warm so they get to lubricate well as soon as the system starts up. They're using a plug system where it actually looks like a half a roll of nickels that's stuck inside the compressor body, or they have a band that wraps around the outside.